Hello everyone, and welcome to another video for this new week, week 3 of quarantine teaching. Hopefully all of you are doing well. I haven't heard from many of you, so if you've watched this video, please send me an email or a Student Square message, a remind message, whatever platform you find most useful. Send me a message, let me know how you guys are doing. Other than that, I guess we're going to get into a little bit of easy content. It's 10:05 this evening where I'm recording this video, so we're going to get to some easy content. We're going to talk about adding and subtracting radicals and then binomial radical expressions. So two very easy topics. So the first thing we need to talk about is adding and subtracting radicals, and it's not a very difficult thing to do, but there is one misconception that I want to bring to your mind. If I were to ask you to perform this operation right here, would it be acceptable to say that the square root of 2 plus the square root of 3 is equal to the square root of 5? So is that allowed? Well, let's think about it in a more numerical sense. What is the square root of 2? Well, if you type it into your calculator, you come out with 1.414. Okay. Well, what about the square root of 3? Well, the square root of 3 is 1.732. This is, of course, approximations. Well, so the question is that equal to the square root of 5? Well, if we sum up these two numbers, we get the number 3.146. Is that the square root of 5? Well, the answer is no, it is not. Because the square root of 5 is actually 2.236. That is not equal to 3.146. Okay, so this is like a little miniature proof showing you that you cannot just add what is under the radical and say that they're equal to some sum of these two radicals. It's not how it works. Okay, there's a few rules that we're going to talk about. Okay, first rule being you cannot do a square root plus a cube root. Okay, remember this is like a little 2. That does not make a fifth root. Okay, so this is rule 1. The real thing is you have to have a square root plus a square root is another square root, or a cube root plus a cube root is another cube root. Okay, so hopefully after these 3 examples you're getting the picture. You have to add, in order for them to be addition, or just go ahead and show it down here, subtraction. For addition and subtraction, they must have the same index. Okay, that's rule number 1. To add two radicals, they must have the same index. Okay, rule number 2, and this goes along with this. Okay, you do not add what is under the radicals. Okay, think of it, the way I want you to think of this rule is think about if I were to do this operation, 1/3 plus 1/3. Well, that does not equal 2/6. We do know, however, that 1/3 plus 1/3 is 2/3. And we know that because we don't add the denominators. They have to be common in order for us to add them, but we add the tops. We add those numerators to get the new number. Okay, radicals function similarly. They function in this way. If I have 2 square root of 3 and 5 square root of 3, I only add, we have to check to make sure indexes are the same, which they are. The next thing we have to check is, are the numbers under the radical the same? These are kind of like our common denominators here. These have to match. If the radicals match, we add the stuff in the front, or subtract depending on what operation we're performing. So we would subtract, or add these in this case. That's going to give me 7 square root of 3. Okay, so rule number 2, radicals must match. Now, that's not to say that if I have this, that I can't do anything. That's not what this says. This rule merely says that if I'm looking at this problem, the only work that can be done is right here, because these have radicals that match. Therefore, I can add the numbers in the front. And whatever's left over, we just make it like a nice little list with plus or minus signs depending on the sign in the front. And there's a simplified answer. In fact, you're going to have several on your homework where it's going to ask you to do an operation similar to this, maybe 3, maybe 4 or 5 terms, and then you just combine the ones that can be combined, and then you leave everything else as it is. All right, so make sure you pay close attention to that. But that's all there really is for rule number 2. Just make the radicals match, which may involve simplification. You may have to simplify a little. But we're going to do a few problems like this that match rule number 2. Okay. Okay, rule number 3. Okay, for rule number 3, which we've already done this in other videos, is distribute. Okay, so if I have root 2 plus 1 and root 5 plus, let's say, 7. Okay, rule number 3 is distribute. And it follows the regular distributive law that we've always followed in class, and we now add in the multiplying radicals that we've already been doing as well. So I do root 2 multiplied by root 5, that's root 10. I do root 2 times 7. So we can't multiply a whole number and a radical on the inside, so we write the whole number outside in radical. So 7 root 2. Okay, 1 and root 5 is just 1 root 5. And 1 times 7 is just the number 7. Okay, well, what if that looked a little differently? What if things could actually combine? Let's say if we had root 3 minus 1 and let's say 2 root, well, let's say 3 as well, just to make it simple. Root 3 minus 6. Okay, what if it looked like this? Well, we still do distributive law. Root 3 times 2 root 3, we just multiply the radicals, so it's 2 root 9. Root 3 multiplied by negative 6 is negative 6 root 3. Negative 1 times 2 root 3 is negative 2 root 3. And negative 1 times negative 6, that's positive 6. Now, we simplify and combine. First thing I notice right here, root 9 I know is the number 3, so it's 2 times 3. Okay, here, these both follow the rule that if they have the same radicals, I can combine the numbers on the outside, so negative 6 and negative 2 is negative 8. And then I've still got plus 6. Now, I can combine this and this. Once it's simplified, 2 times 3 is 6. So I'm going to combine 6 and 6 and make 12. And then I bring down my 8 root 3. And that's a simplified answer. Okay? But notice this is not a difficult process. Distributive property, simplify, combine like terms. That's all that we're doing. So we have distribute, simplify, and then combine like terms. All right. So now let's get into what we're actually going to be talking about. Let's do a few problems. Remember that this is Algebra 2, so not everything is going to be friendly and numerical. Sometimes we do have to worry about variables. So I'm going to put a few problems up here. I'm going to put them in blue. So number 1, we're going to have 3 root 5x minus 2 root 5x. Number 2, let's say we have 6x squared root 7 plus 4x root 5. Number 3, 3x root xy plus 4x root xy minus 7x root xy plus 10x squared root xy. And let's add one more just to make it fun, minus 3 root xy. Okay, that's a fun one. And let's do one more. Let's do a little bit more simple one. Let's do 5x squared cube root of 7 minus 3x squared cube root of 7 plus 2 cube root of 7. That way we get 2 that have a weird answer the way we're going to write these. Okay, starting with number 1. First thing we check, indexes are the same. That's rule number 1. Do the indexes here match? They do. They're both square roots. Second thing we look at, do the radicals match? What's under here and the radical itself with the index, do they match? Well, this and this are the same, which means if it follows rule 1 and rule 2, that means they can be combined. So that means I put the negative 2 and the 3, I put them together. So I get 1, which we don't have to write, root 5x. Alright. Okay, next one. We look. Do they have the same index? They do. They have the same index. They're square roots. Rule number 2. Are they the same under the radical? No. Automatically we can see a 7 and a 5 are not the same, which means that this has no simplification. Now, it'd be a little bit different if I could make these two radicals match. And I'll make sure to do one of those in just a moment, but there's nothing I can do here to make these match. Okay, down here, I need to check, and let's make sure that this 2 here is not confusing anyone. That is with the x. So it's an x squared, not the index. Okay, so 3x root xy, got a bunch of root xy's. Rule number 1, indexes, checked those. All of them match. Second thing, is all of these radicals the same? And the answer is yes. They are. They're all the same. And because they are all the same, that means that I can combine them. So I need to combine a 3x with a 4x with a negative 7x with a 10x squared and a negative 3. Well, right here, 3 and 4 makes 7 minus 7. So these 3 cancel out. All I'm left with is 10x squared and negative 3, which I cannot combine into a single term. But what I can do is write them as a binomial. I can write it like I see it. 10x squared minus 3, and we put these in parentheses. Out here to the side, I'm going to write what the radical is, and it's radical xy. It's almost like we factor, well, it pretty much is, like we factored out this square root of xy. We factored it out and just have one of them. Because think about it, if I go and distribute if I were to distribute square root xy to both of these, I'd be right back to this original statement. Alright, the final one on here, 5x squared, cube root 7, all of these. So we check, rule 1, they're all cube roots. So that's a good sign. All these radicals match. That means I just combine everything in the front. So 5x squared and negative 3x squared, that is a 2x squared. And then I have the number 2. Well, this is a binomial, so we'll put parentheses around it, and we write whatever the radical is out here, cube root of 7. And there is my answer. Okay. Now that we've covered that, there is only a few problems that I want us to look at left. And these are some of the longer ones, and they involve more of the simplification. And let's look at these one at a time. So the first one is negative 3 root 45 plus 2 root 12 plus 3 root 6 minus 3 root 20. Okay, so what I want to see if I can do is I want to see if I can get these radicals broken down where they match. If that's possible. It may not be. It just depends. But let's start with the obvious. 45. I want to know what perfect square, remember we do have perfect squares that we've talked about before. 1, and I about wrote the number 9 and skipped one of them. 1, 4, 9, 16, 25, 36, and so on. Remember, all we're doing is 1 squared, and then 2 squared, and then 3 squared, 4 squared, on down. That's how we generate this list. Is there a perfect square from my list that divides into 45? And the answer is yes. It's right there. So I've got negative 3 square root of 9 times 5. So that was simple. That was pretty easy. Now what I want to see is, can I do that with any others? Well, with 12, I'm going to underline them in the color that I'm using. So I used blue for the 45. Now I'm going to switch to green for the 12. And I'm going to use green for this one as well, because they're going to use the same number. So 12 and 20, they both can be divided by the perfect square 4. So it gives me 2 root 4 times 3. 4 times 3 is 12. And actually I'm going to write this one other way just to make it a little simpler in my mind. Root 4 and root 3. I'm going to go back and change this one over here. Root 9 and root 5. For some reason in my mind, I just like the way this is written better. I guess it's whenever it simplifies, the square root falls, the number changes, and I put parentheses around it indicating multiplication. Somewhere in my mind that just makes sense. 3 and root 6, none of my numbers will work with 3 root 6. So he just comes down. He's going to hang out for a little while. Okay, switch back to green again so I can work with this radical. 20, as we said before, can be root 4. So I've got negative 3, I've got a root 4, and 20 divided by 4 is the number 5. Now I'm going to go through square root of 9 we know is the number 3. Go ahead and do my green. We know square root of 4 is 2. We still have that 3 root 6. I've got negative 3, and we know square root of 4 again is 2. Okay. Now multiply parentheses, so negative 3 times 3 is negative 9. 2 times 2 is 4. We've got 3 root 6. And negative 3 times 2 is negative 6. Now what we're going to look at is, do any of these combine together? And we've got two candidates here and here, because they both have square roots and they both have the number 5. Therefore, we're going to combine the numbers in front. So I've got negative 9 and I've got a negative 6. Combine them together and get a negative 15. And then everything else, these two cannot combine, so we make the list. And that's going to be our answer. So the steps are simplify, break down, multiply, combine like terms. All right, let's do another one of these. Let's do one with cube roots. So negative 6 plus cube root 54 minus cube root 16 plus 5 cube root of 32, get that out of the way, plus 3 cube root 81. Okay. Well, right off the bat, we're not worried about negative 6. It's just a number. Cube root of 54, remember cube roots, move that out of the way again. Cube roots are formed by cubing numbers. So 1, and then I have 8, and then I have 27, and then 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125, 216, and the list goes on. Remember, that's 1 cubed, and then 2 cubed, and so on. Okay, so we're going to be using that list to try to break these down if we can. Same thing, I'm going to be switching colors to indicate where I'm working. So I'm going to start with blue with the cube root 54. Cube root 54, I know off the top of my head, and you can always just take this number and then divide by these to see if they work. It'll have to come out to be a whole number. But I know that the cube root of 54, 27 divides into 54. So the cube root of 27, and 27 times the number 2 will make 54. Okay, switching over to green, I'm going to be using, I'm going to go ahead and indicate it here as well. I'm going to use that one twice. So, I'm going to go ahead and indicate it over here as well. Okay, so I'm using just blue and green to match the colors with the cube roots. So 16 is 8 times 2, so I've got negative cube root of 8 and cube root of 2. Here I've got 5, and then I'm going to have the cube root of 8 and the cube root of 4. So 8 times 4 is 32. And finally in blue I've got the cube root of 27 and the cube root of 3. 3 times 27 is going to give you 81. So now, simplify things. Still got the negative 6. Cube root of 27 is the number 3, so I have 3 cube root of 2. Then moving down, I've got cube root of 8, which I know is the number 2, and then I have the cube root of 2. Plus 5 multiplied by the number 2, because cube root of 8 is 2, with the cube root of 4. And finally, in blue at the end, I've got 3 and the cube root of 3. So in this case, I'm going to go ahead and fix this right here. This, I'm not going to do that. I'm going to do 10. 5 times 2 is 10. I only have one spot, and that's these two here that can be combined together. The others can be were simplified, but these two are the only two that can be combined. So I've got the -6. I'm going to combine these two. I'm going to get the cube root of 2, because 3 minus 2 is just 1. And then I have 10 with the cube root of 4. And finally 3 with the cube root of 3. And this would be my answer. So simplify them as much as possible. Go down as far as you can. And then combine any like terms that you can. Sometimes there will be only one set that can be combined. Sometimes there will be multiple sets. But combine what you can. Simplify as far as possible. Okay. Last thing I want us to talk about is the binomial. I just want us to do one more of those, and then we're going to be done for this evening. We are going to do this one. It is 5 minus root 7 and 5 plus root 7. Okay. And actually, let's put an x in there. We haven't done any with x's in a little bit, so let's do some x's. So here, this is going to be FOIL or double distributive, depending on what method you employ. So 5x times 5x, I meant to say employ, not implore. 5x times 5x is 25x squared. 5x multiplied by root 7 is 5x root 7. Negative 7 multiplied by 5x, well, it's negative 5x root 7. And negative root 7 multiplied by root 7 is negative root 49. Well, right here in the middle, positive 5x root 7, negative 5x root 7, those cancel off. So I've got 25x squared and negative 49 under the radical. Radical 49 is just 7. Okay. This follows the pattern of, see if anyone recognized it, the difference of two squares. Technically, this could be factored into 5x minus root 7 and 5x plus root 7 if we were asked to go backwards. Okay. Well, with that, ladies and gentlemen, that is all I have for you for this week. You have one IXL assignment or one paper assignment, depending on which route you're going, online instruction or paper-based instruction. So make sure you get that completed. If you're doing the IXL, you know you don't have to do anything extra. I get your scores once you're finished. Paper, you need to either send me a picture or drop it off at the school so I can pick it up and grade it. But other than that, make sure you guys email me this week and let me know how you're doing, if you're doing okay. And it can be just a simple message, hey, Mr. Reed, I'm doing all right. Just reach out to me. I haven't heard from you guys. Get in a worry. Okay? So, I guess I'll see you guys in the next video or through correspondence on any of our platforms. See you later.